This is an at-home video of the Archimedes device. When you go on Google Classroom and click on your assignment doc, you will see multiple assignments, lessons, video clips, or whatever of the Archimedes device that deals with displacement and buoyant force. What we're proving here is that Archimedes' principle is in fact true. And what Archimedes' principle is telling you is that the buoyant force exerted on an object in water, that's that weight that's going up and down, the buoyant force, the upward force, is equal or the equivalent of the weight of the water that's displaced. Now, when you look at the French documentation, it will talk to you about how the scientists of the day in Paris around 1802 or so created the metric system, and they designed it around a cubic centimeter of water and its weight. So a cubic centimeter of water was defined, the weight of that cubic centimeter of water was defined as 1 gram. It was created purposefully so that you would have a numerical equivalent connection between weight, grams, and volume, which is cubic centimeters, also known as milliliters for fluids. So if we look very closely at this, we will see that the weight, when it goes in, increases the volume of the water in the graduated cylinder from 175 milliliters, or cubic centimeters, they're the same, and then when it gets lifted out, it goes down to 175, meaning there is a fluctuation in volume of 25 milliliters or cubic centimeters. Now, for the tricky part is to get this thing focused on the spring scale. And if we look closely on the spring scale with Mozart in the background, I need a white piece of paper. I'm putting it on pause and then continuing. Okay, welcome back. I now have a paper behind the spring scale. We're hoping that you can see the changes in the spring scale. I'm going to hold the camera and maybe lift up the paper so that you can see. If we look carefully, you should see that the spring scale fluctuates between 175 grams and 200 grams. Hopefully you can see the number. There's a 200 there, and then as it goes in the water, you can see it's going in the water. It's going to 200, but here it is registering on 175. So I'm just going to stay here for a while so you can see the changes. See, it's gone to 200. That means it's out of the water. That's 200 grams weight of the object that's going in the water. And now as it's going in the water, it is being reduced to 175 grams. Now I'll just hold it for a while because it's starting to show itself. It is now out of the water at 200 grams. See, it's out of the water. And then it's back in the water at 175. So observing this at the same time, you can see, this is hard for me to do, I only have 2 hands, that it's as the water goes down, the spring scale goes up, and then as the water rises, as it's inserted inside, you can see that the spring scale is rising. So the movement of the absolute numbers is there, it's opposite. When the weight goes down, the volume of water displaced goes up, and when the volume of water displaced goes down, the spring scale goes up. And this is proof that Archimedes' principle, which again I will state, says that when an object is put in water, or a fluid, any fluid, but in our case water, that the buoyant force exerted on the object, which is the loss of weight on the spring scale, the buoyant force is equal to the weight of the water displaced. And the weight of the water displaced is that 1 cubic centimeter equals 1 milliliter. That's the 25 fluctuation of milliliters or cubic centimeters of water, that the buoyant force is equal to the weight. So therefore, if it changes 25 milliliters, the weight of the water displaced is 25 grams. And you can see that the change in the spring scale is 25 grams. So this is the Archimedes device. The documentation of everything is such that, well, we'll keep showing you this. The documentation that's on Google Classroom, you'll find the doc, you'll find Archimedes Lab. You need to, your responsibility at home for homework is to review the documentation, see what it's in writing. Maybe there might be a video, I don't know. This video is on it, of course, because that's where you're going to get it. Although I'm going to try to have it so that it can be played in class today. And you're able to get it and access it by yourself at home, sort of like remotely, hybrid, and be able to do your lab report, because there is a Archimedes device lab report rubric, there's a worksheet, there's documentation, there's information on the metric system. And then eventually we'll understand that when we know these calculations and you do your boat, you will be able to predict. Can you see how it goes up and down on those lines? Well, those lines represent the changes in water displaced, and that's what your water lines on your boat will be when we get to that. So just bear in mind when we're dealing with water lines and figuring them out and calculate them and putting them on your boat, that this is a demonstration of the phenomena so that you can understand what you're doing and why you're doing it and how the science applies. Thank you. I hope this worked for you.